Hello, everyone, and welcome to Building SaaS on AWS, the flagship show for building SaaS here on the AWS Twitch channel. My name is Gunnar Grosch. I'm a developer advocate at AWS, and this is the show for SaaS builders. So if you're building or planning to build a SaaS product, this is really the show for you. What we do here is that I bring on SaaS experts to talk about specific SaaS topics so you can learn more about building SaaS on AWS. And this week, I am joined by two guests. We have our recurring friend Ujval joining us, and we also have John Handler joining us. Welcome to the show, both of you.
Thank you, John.
Thanks.
So let's do the quick round of introductions. Let's start with Ujval.
Hi, as Gunnar said, I'm Ujval Bakka. I'm a partner solution architect from AWS SaaS Factory team. My team primarily helps various ISVs and enterprises to build SaaS solutions on AWS. So we provide business and technical guidance to accelerate their SaaS journey.
Welcome to the show, Ujval. And then John, first-time guest on the show. Welcome.
Thanks so much, Gunnar. So John Handler, I'm a solutions architect with AWS, and I'm actually a specialist with Amazon OpenSearch service. Looking forward to talking about OpenSearch and multi-tenant OpenSearch today.
And if John is very still for you as well, I guess John is having a bit of an issue with his video right now, but we can hear John at least. So yeah, let's see if maybe John can reconnect.
Yeah, sorry about that.
No worries.
I don't know why my camera turned off.
Well, hopefully you'll be
weird.
right back.
Let me try restart it here.
Yeah,
of course.
No worries.
We get some nice technical challenges right at the beginning of the show. I don't actually know what's going on. Maybe we'll just go audio for me. Yeah.
Well, maybe John, you can reconnect to the streaming platform and
okay.
Let's.
Yeah. Why don't I do that?
Works better that time. Yeah. And in the meantime,
all right.
See you in a bit, John. So in the meantime, Ujval, maybe you can tell people a bit about AWS SaaS Factory.
Sure. Yeah. So as I was saying, we are a team which has a technical team and a business team. We primarily what we do is we engage with various enterprises or partners, and then what we typically do is help them to first of all we'll help them to understand how to build the SaaS solution, and then we'll provide you from a business perspective and from a technical perspective what are the different ways they can accelerate their SaaS journey. So they'll be successful in delivering their SaaS solutions on AWS. So I'll be quiet now. John is back, so hand it over to John.
All right.
We can even see John moving this time. So
that's great.
Yeah.
I like it better when I move than when I'm completely still. So.
That's good. And well, as I said initially, each show we have a specific topic to talk about, and this show is of course no different. And this time we're going to talk about storing multi-tenant SaaS data with the help of Amazon OpenSearch service. So a good way to start with this, maybe, John, is to talk a bit about OpenSearch and what OpenSearch is.
Yeah, sure. So OpenSearch is a search engine in a box, basically. OpenSearch is search technology. It's an open source project that is available to the world. It takes in your data. It enables you to search over that data. And it also takes streaming log data and enables you to build visualizations and dashboards to do real-time monitoring, to do container monitoring, observability, security, and event monitoring. So it is a solution that sort of enables those workloads. Yes, right. So did I lose you guys? Yeah, okay.
Sorry?
Everybody froze for a second.
No, we're just listening eagerly to you, John. So no worries.
Okay,
so
fair enough.
In the episode title, we have Amazon OpenSearch service, and that is the AWS managed service. But there's also another OpenSearch. Maybe you can explain the difference between these two and the similarities.
Sure. So Yeah, so OpenSearch itself, again, is an open source project. With Amazon OpenSearch Service, we provide the managed service to run, deploy, scale, operate within the AWS cloud. So that just enables you to use that OpenSearch project within AWS as a managed service. So the managed service does provide additional benefits in terms of security, easy scalability, easy deployment, and sort of the operational backend that the service brings to kind of keep the lights on, monitor things 24/7, and make it easy to operate OpenSearch in AWS.
And Ujjwal, maybe you can add in. Do you see customers using OpenSearch today for SaaS solutions?
Oh yeah, definitely. So they, primarily on the log aggregation stuff. So when they get this tenant data, they use this platform to aggregate the logs and then search for tenant-specific metrics or data, and they try to visualize that data using the dashboards offered by OpenSearch to see how tenant-specific data is. They can tenant-specific metrics, and also as a control plane and tenant as a control plane, the SaaS admin can also build dashboards using this open search dashboards to see the data across all the tenants, to see which tenant is using how the resources and etc. and all that stuff. Yes, we see a lot of customers using. That's one use case, and as John mentioned, the search use case, where if they're providing some kind of a functionality around search, they do use those this open search service.
I think the logs use case, there is a large portion of our workloads, and when we look at multi-tenant usage, and especially as we get into it, we'll talk about tenancy at sort of different levels. But with log analytics, you do see typically a centralized logging environment where you have an IT department that is vending out OpenSearch for their developer groups to bring their log data in and do the dashboards and visualizations, right? So tenancy there really is a lot about the different groups, different development groups that you find in a large organization and managing those together. There are other multi-tenant workloads sort of within log analytics, but that's kind of the core one. We do have a lot of different tenancy models for search, and especially for SaaS solutions. You very frequently have a SaaS solution where you have a number of customers, of course, and all of those customers are bringing their data. You want them to be able to search their data set, and you want to co-locate those all within a single Amazon OpenSearch service domain. We'll get into a little bit what is a domain, but within a single domain for easier operations and easier management of that collection of workloads. So in the SaaS world, again, we often see applications that bring their application data per tenant and provide search across that. We often see even sort of different portions of catalogs, like you could think about different languages coming in. There's a lot of different tenancy that happens within the search world as well.
So maybe we can dive in a bit and you show us how it actually works, John.
Yeah,
I think
sure.
You have some slides
yeah, let me
to show us
just bring up my screen. Sure. So are we seeing that? Do you have my screen?
Yes, we can see it.
Fantastic. Yeah, so OpenSearch is actually a database in the database world. I like to think of a search engine as way cooler than a database, but I know the database fans out there, they're probably going to be mad about that. But I think search engines are super cool. But they are in the databases world, and so the interaction model is very familiar if you're familiar with databases, right? Fundamentally, you have a source of data here, which is either going to be your server logs, your application logs, networking logs, AWS logs, any kind of logs that you're collecting. And then on the other workload is you have your application data, again, whether it's your individual application tenant data or what have you is coming in. OpenSearch is a REST API, so it's all JSON backed. You'll take the data and convert it into JSON, depending on what the source is. There are lots of different ways that you do that. That application data will come in as JSON documents to Amazon OpenSearch service. where it is indexed and searchable, right? So one of the differentiators that OpenSearch has with respect to compared to a relational or other database is that every single field in the JSON is searchable, even down into the nested levels of JSON. So all of the data is searchable. And on the query side, again, the interaction here is you have your users, your analysts, your DevOps people, your security people, depending on what the workload is. They're going to generate queries. Those queries are JSON based. There's a query language that enables searching across the different fields in the document with Boolean logic and with an inbuilt notion of ranking, because all search engines have a notion of ranking and scoring that try to bring relevant results for what those queries are. And frequently, like if you think about, you go to Amazon.com and you want to search for a product, you hope to get the product that most closely matches your search terms and is the thing that you were intending when you type that, right? So again, differentiator for search engines is this ranking and scoring. But in either case, you have REST APIs, you send that query in, and the results come back out. So really familiar interaction model, pretty lightweight to deploy and to use.
And then moving from there, then looking at, I think you touched upon a couple of use cases, Ujval. Maybe we can talk a bit more about the use cases that we see for OpenSearch in SaaS.
So yeah, as I said, like one of the main use case is the log aggregation one, where you have your SaaS application, and then that SaaS application is spitting out the logs, which has the tenant context in it, and then they usually what we see is like they aggregate these logs and push it out to the OpenSearch engine, and then in the OpenSearch once we have with the tenant context information, the documents which has with the tenant context information, then we'll talk that through in a bit here, how you can use this OpenSearch to do different kind of models like silo model, a pool model. As you see, a silo model is a model where you create a separate set of resources just for a particular tenant. So we try to apply that. Most of the people try to apply that to the OpenSearch in a certain way, and they also use a pool model where they're sharing this one OpenSearch domain across all the tenants. And again, there they have all the tenants' data and try to pull the data from that OpenSearch engine and see that. That's the primary use case we usually encounter with the log aggregation. Not to say that as John was saying, even the search engine, it's also used as a search engine where some SaaS solutions offer some kind of a search functionality where they try to use this as their backend. So yeah, these are the primary use cases we see in the SaaS world with regards to the OpenSearch.
And then next, John, should we dive into the architecture, maybe look at some examples?
Yeah, sure. So when you use Amazon OpenSearch Service, you create what we call a domain. So a domain is a collection of hardware and software that delivers OpenSearch to you at a REST endpoint where you interact with the query and indexing APIs. If we dive in a little bit, OpenSearch is a distributed database system. So it is deployed onto a collection of instances that the service manages and brings up for you. We have different classes of instances. So within them, we have data nodes. The data nodes hold the data. They respond to the queries. They respond to indexing requests. The work happens on those data nodes. Two flavors actually of data nodes. So we have hot data nodes which provide fast access, fast indexing, higher CPU. Those hot data nodes really are the workhorses. We also, and especially for log analytics, we find that the data itself becomes less valuable as it ages out, right? So a lot of the workloads here really are for logs are going to be related to real-time infrastructure monitoring, security monitoring, different application performance monitoring, like lots of different monitoring focus for OpenSearch, right? So the data is really most valuable for the first 15 minutes of its life cycle, but often you want to retain that data for a longer time period, either for compliance reasons or for the ability to go back and analyze what past behavior, analyze and find stuff that happened in the past. So the value, drops off rather sharply, but you want to keep that data in the domain. So we came out with a feature called UltraWarm that is a set of data nodes that are backed by S3 storage and that manage a local storage to cache the data out of S3 on demand. This gives you a slower performance, but it gives you a much reduced cost structure. So as data ages out and as you have the life cycle of the data, you're going to move it from that hot tier into the ultra-warm tier. Eventually, we also have a cold storage feature where you can detach indices from your domain entirely, leave them at basically S3 cost, and that gives you a extremely long-term retention strategy where you can keep things for up to years. We have customers that want, for compliance, to maintain their data for 7 years. So the data nodes and the ultra-warm nodes really are going to provide the processing infrastructure. Then you have cluster managers. These nodes actually maintain the cluster state and maintain the cluster as a cluster. If you're familiar with Zookeeper, they're a little bit like Zookeeper, but they're not actually Zookeeper itself. We're fronting the whole thing with a load balancer, and that enables distribution of the requests across all of the infrastructure here. And we have integrations that make it easier to use the service. So we have integrations for Cognito, IAM, SAML. OpenSearch itself is the OpenSearch engine, and we also have OpenSearch dashboards, which is a UI layer where you can log in and you can build your visualizations and dashboards in OpenSearch dashboards. So for OpenSearch dashboards login, again, SAML and Cognito, that gives you a means of federating access to the dashboards in the domain. We also have CloudWatch, CloudTrail. The service sends out metrics to CloudWatch and audit data to CloudTrail, so you can monitor what's going on. The service itself is responsible for deploying. You tell the service how many data nodes you want, what type they are, how many cluster managers, and the service goes and deploys them. But when you use the service, you do monitor the metrics and the performance of the domain within CloudWatch to be able to react and scale. You can scale Amazon OpenSearch Service domain by issuing an API call. The service goes and does all of the scaling activities for you. But you do have monitoring that enables you to understand how your workload is performing and how you need to scale. On the inbound side, we do have integrations with Kinesis Data Firehose, database migration service, CloudWatch logs via Lambda, and managed streaming for Kafka via connectors. So we have a lot of different ways to get data into the domain that are more automated than directly calling the indexing APIs. So that's kind of an overview of sort of what is Amazon OpenSearch Service and what is it deploy and how do you use it.
And a term that is commonly used when we're talking about this is sharding. So maybe I think we'll probably use that a couple of times throughout as well. So maybe, John, you can explain a bit what sharding is and why that is important.
Sure. Let's talk about sort of the data disposition and within OpenSearch and how you interact and store and manage your data. The core entity within OpenSearch is called a document. The search document really is a single instance of a JSON blob, right? If you're talking about logging, then a document here would be a log line. And generally, you take that string, because a log line is a string, you have various technologies and means for parsing that string up, turning it into a JSON document, and sending it into OpenSearch. Obviously, on the search side, if you're using a relational database or other sort of structured data store, you'd pull the columns as the individual fields, and you build the document based on the row of data that you have in that other data store. So you create these documents and you send them in. The core sort of collection within OpenSearch is called an index. The index then manages a set of documents, right? So the index is the main sort of data container. You can think of it like a database table. And again, just to make the analogy, you have your table is index, you have document is row, and you have field in the JSON is column, right? So it has a familiar kind of feel. Then the indexes themselves are partitioned into shards. So when you create that index, you set a shard count, and the data is randomly hashed across those shards, right? So shards are individual partitions of that full index table. Shards are really key. The shard is really the main unit of storage and work, and we'll get into that in a second. The shard is the really important concept to understand, especially one of the sort of ways this plays in multi-tenancy is that shards themselves are distributed to the data nodes within the domain, right? So if I have an index that has 5 shards, then all of those shards will be placed within the data nodes of the domain, right? And the shards themselves are actually instances of a Lucene index. Lucene is a Java technology to read and write search indices, right? So each one of these, again, is a unit of storage and it's a unit of work. As you look at how you shard out the data, the mapping of shards onto data nodes is how the resources of the cluster are put at the workload, right? So in this case, if we have 3 shards on this node, then you have each of those shards is, I don't want to say competing. Each of those shards is using the CPU and the storage and the Java heap and all of the resources of that instance, networking, all of that. So this is sort of how the data lays out when you send it into OpenSearch.
And how much do you need to think about sharding when you're architecting your solution?
Yes. So again, shards are the unit of work. So it's I'd say job one is to sort of figure out the optimal relationship of the optimal shard count for your index, and then the relationship of the shard count to the node count, so that you're not packing too many shards onto a single node where they're overwhelming and there's not enough resource, right? So sharding is key. I can say just a tiny bit. There's a whole discussion we could have about sizing and capacity planning for OpenSearch, but if we talk about specifically shards, the shard again is the parallelism of the query and indexing workload, right? So as we look at it, the shard size is kind of a proxy for usage, and we generally would say that you want to take your index and split it so that your shards are about 30 gigabyte for a search workload, 50 gigabyte for a logs workload, and that's how you figure out your initial shard count. Then you have to POC and try and test and tune and do all that. But the initial shard count really is based on size, is how we do it.
All right. So this is Building SaaS on AWS. I'm joined today by Ujval and John, and we're talking about OpenSearch and talking, of course, about multi-tenant tenancy when it comes to OpenSearch. So how to store multi-tenant data with Amazon OpenSearch service. If you have any questions, comments, just pop them in the chat. And maybe now is a good segue to having a look at the different type of tenant isolation models that we can implement.
Sure. Yeah.
Go for it.
Yeah, sure. So before I dive deep into the isolation models, I briefly touched upon what is a silo model and a pool model. I'll just back it up and introduce that model, and then walk you through about how you can implement those models in OpenSearch service. So silo model is a model where you create a separate set of resources just for a specific tenant. Pool model is a model where you share the resources across your tenants. It depends upon your requirements whether you take a silo approach or a pooled approach. I won't go deeper into details in there, but what I'll walk you through here now is how you can implement the silo model and the pool model in the OpenSearch service. The slide you are seeing here is basically showing a silo model where we are trying to show, you can build a domain per tenant, where you create a separate domain for each tenant. Like as shown in the slide, for tenant 1, there is a separate domain, and tenant 2, there is a separate domain. And the isolation story here is you can, at the domain level, you can set the resource-based policy. It's called domain access policy. It's an IAM role, which gives access to an IAM user or a role to access this particular domain. And if you talk about typical workflow, what you will have is like, you have a microservice which assumes a role, and that role will have access to this particular domain. And probably you will have some kind of a table or something which maps this tenant to this specific domain. So when a request comes to this microservice will look up to this table with the tenant information, and it knows which domain it needs to go, and then makes request to this OpenSearch service domain. And then since the OpenSearch service domain has its resource-based policy, or the domain access policy, which gives access to this particular role, which is assumed by this microservice, the request would go through. So that's how you implement a domain per tenant model. And under the silo model, there is another approach you can also take, that is index per tenant. And yeah, John, this slide shows you how you can build index per tenant. And again, here you have one OpenSearch service domain. Under this one OpenSearch service domain, you're creating indexes for each tenant, like as shown in the figure here or in the slide here. You have tenant 1 index and tenant 2 index. And the isolation story here is what you can use here is a fine-grained access control feature, which is provided by, it's basically an OpenSearch security plugin, where it gives you a flexibility to define roles, which gives access specifically to this particular domain. So what you specifically do here is, like in OpenSearch, you will define a role, and under that role, you can specify the index permissions. Let's say if you take tenant 1 here, what you will do is like you'll create a tenant 1 role, and which gives access only to this tenant specific tenant 1 specific index. And then what you will do is you will map this role to an IAM user, or to an IAM role, or just an OpenSearch user. And that's how you would restrict or isolate a particular tenant to have access to this particular tenant's index. And moving on, the other approach
before we move on, I just wanted to come back 1 second to Gunnar's point. When we have this multi-index situation, this is where the shard strategy becomes absolutely critical, because what you have is, and especially as the index count goes higher, you have a large set of shards that are vying for CPU and other resources, right? So the shard strategy here is really important to look at how many shards are mapped onto how many data nodes there are in the domain. And we kind of shoot for a ratio of one shard to 1.5 vCPUs, right? So if these two indices, end up with 5 shards on a node, we'd like to have about 8 processors on that node, right? So 2/3. So that, again, just as we think about size and capacity planning, in this situation, it's where we tend to stress the hardware the hardest, because there's a lot of concurrent work going on across these different tenants. Thanks, Ujjwal. I just wanted to drop that point in there quickly.
Sure. Why not? So moving to the pool model. So again, in the pool model here, how the way you can implement is like under the OpenSearch service domain, what you can have is one pooled index, and that pooled index would store all the documents of different tenants. So basically, you're sharing this one particular index across your all your tenants. And the isolation story here is, again, we will leverage the fine-grained access controls feature. Here, instead of using the index permissions, I mean, obviously we will use index permissions, but in order to go, provide that fine-grained access, you would go one level deep level, and use the document level security feature, which is provided by fine-grained access control. So basically, with that feature, what you will do is, like when you are defining the OpenSearch role, you would give access to this pooled index, and then you would say, hey, give only access to these documents which has certain ID in it. Like in this case, you would say that, hey, for tenant 1, give access only to the documents which has the tenant ID equal to tenant 1. That way, even though this particular index or the pooled index is shared across all the tenants, you have defined a role for a particular tenant which gives access to only specific documents with specific attribute value. And then you map this role to the IAM user, or a role to the OpenSearch user, so that you build this kind of an isolation. That's how you implement the pool model. And moving on, the hybrid model is just combination of both too. Like you can have a silo model or a pool model. And the reasons why you build an hybrid model in a SaaS solution is basically, you usually, when you build a SaaS solution, you have different tiers, and platinum tier and a basic tier. For platinum tier, since they're paying the premium price, you want to have a different experience for them. So you build that with the silo model, and basic tier, you would just use it to the pool model. And again, the isolation story is the same thing. It's just that we are combining both of them, so we call it as a hybrid model here.
Right.
So I would also say,
go ahead, John.
I would also say that generally, when I talk with customers, work with customers, we end up in some kind of hybrid model, because whether it is based on sort of licensing or a purchase of a particular product, or it's based on just the different sizes of the tenants and different usage that they drive, you frequently end up with some set of pooled tenants that are really the lower usage tenants, and then some. When you have the order of magnitude, 2 orders of magnitude larger tenants, it makes sense either at an index level to split them out, or at a domain level to split them out, which makes for more efficient scaling, right? You take that much larger tenant and you can optimize for scale, for size, for that particular tenant, which can actually help a little bit in your cost structure. The other thing I'll mention is that data isolation may actually drive your choice of the tenancy model as well. We do have scenarios in customers where data cannot commingle, and in those cases, you have to do sort of a siloed domain per tenant model. And so if you have those regulatory or other needs, then it can also force your hand a little bit in terms of which model you choose.
And looking at from the consumer side or the user side, there is no real difference between the different models. So it's basically the role that would then dictate which access they get, and perhaps different endpoints depending on
right.
the setup.
Correct.
So we have a question from the chat. So let me bring that up. From Binary Monk 01. For silo domain, encryption key per customer becomes possible. For silo index or pooled, do they have options for different encryption options for the data indexes, or must it be a single shared encryption key?
Yeah, so I can take that. At present, the service allows 1 encryption key per domain. So at present, we do not support the pooled model with different encryption keys. So that's another thing that can force your hand into choosing the domain per tenant, is if you have different encryption needs, or if you need a key per tenant. Yeah.
All right. So keep your questions coming if you have other questions for our experts. Was there any other slide there, John, or Ujjwal?
Yeah. Yeah, maybe we can talk a little bit about this. I think Ujjwal had shown the sort of application microservice and how it was kind of relating to IAM. And I point folks at the YouTube talk. This is from reInvent. It's actually quite a bit ago. It's actually 2018. But we had NBC Sports Engine talking about their multi-tenant SaaS solution. So NBC Sports Engine runs youth sports organizations. They have about, I think, 20,000 or so of those organizations. They manage the membership, they manage the games, they manage sort of all of the different sort of jobs in a per tenant model, in a SaaS model, right? And so they went through a whole journey with figuring out their tenancy strategy within Amazon OpenSearch service. Well, actually Amazon Elasticsearch service at the time. And one of the things that was really key that they built was an associated database that helped them manage the tenants within their deployment, right? Within that database, you have per tenant an endpoint and an index name that enables you to the application to take all the traffic on an update request or read operation that indirect through this database, and it would enable them to direct the traffic to the correct location. This is a good strategy anyway to maintain that endpoint and index in an external, other system that would enable you, even if you're not running a SaaS solution, just if you're running even a website and you want to run search, having this indirection helps you manage and do cluster changes and other things like that. But in their case, the tenant then they had a couple of flags, especially the read-write status. What they could do is disable writing for a particular tenant. And you can see on the bottom, they have a spin lock. They have a queue that they just take the update requests and requeue them while they're waiting, while it's in read-only status. They can then take from their source, they can take that tenant's data, index it in a completely different place. Like if they want to move that tenant off into its own domain, they can simply create that domain, re-index it, flip the pointer in the database, and then enable writes again. So in this way, they actually could manage the tenancy within OpenSearch service and enable sort of moving tenants around. Like you often get into these situations, you have a large tenant or a tenant grows really quickly, and then you need to move it or put it in its own location so you can scale for it. So this mechanism really is very helpful in managing tenancy within Amazon OpenSearch service. So I thought it was worth sort of sharing that. I recommend that talk. It's kind of a fun talk. Sports Engine starts at minute 30. You don't have to listen to the first 30 minutes. That's just me. So, but this is a really great piece.
That's great. Maybe we can get our chat mods to share the link in the chat as well. So Ujjwal, I think it's time to jump over to seeing this in practice as well.
Sure. Yeah.
As always, prepare the demo for us.
Yeah, sure. Can you share? Yeah. Let me share my screen. So what I'll do now is we talked about the silo model, domain per tenant, and then index per tenant, and the pool model. What I'll try to show here is how you can build this isolation. Basically, the one which I explained, I'll try to show the concrete examples with that. So to start off with, for the domain per tenant, I just created one specific domain, and as I mentioned, the isolation story here is to create a domain access policy which gives or restricts access to a particular domain. The sample policy would look something like this, where you have these specific role or something which gives access to certain set of actions which gives access to this particular domain. Or in this case, the domain is this the domain per tenant domain which we have just created. So the isolation story is straightforward in the domain per tenant. Whereas moving on to the index per tenant, let me log into the OpenSearch UI here. What I'll show you here is I will log in with an admin user, and what I did here is I've created a couple tenants, tenant 1 and tenant 2, which uses index per tenant model. I'll walk you through those roles, and then try to use that roles and show you how we are restricting access to this particular tenant. So let me log into the admin user here.
John, in the meantime, since we've been talking both about OpenSearch service in AWS and also OpenSearch, the open source project as well, is this the exact same thing as soon as you log in, or is there any difference in flavor between the two?
They are the same. Obviously, the service itself has some limitations around the customizations and other things that you can do. So if you're running open source, you might have a different sort of skin on the UI. You might have enabled or disabled various of the tabs that you can see on the left, the different panels within OpenSearch dashboards. But yes, it's exactly the same service and open source.
Great. All right, Ujjwal, back
All
to
right.
you.
Yeah. So let's look at these two roles. That is a tenant one role and a tenant two role. If you look at here, it is only giving permissions to this tenant one index, this role, and then this the other role, tenant two role, is giving permissions to only this tenant two index. And if I click on this role, and again, what it has is some basic permissions, and I just gave some read, write, access permissions, nothing fancy here. And this role I've mapped to a user called tenant one user. So this now tenant one user will have access only to the tenant one index. So what I will do is, again, is like I'll use this tenant one user and log into this portal and try to. I've already created some documents for under this index, tenant one index, and I'll show you can access the documents under this tenant one index. But if you try to access the documents which are under tenant two index, it will restrict and it would allow you to do that. So let me try to log in now with another.
Let me just say a quick word about the fine-grained access control. You know, within OpenSearch itself, and the security plugin maintains an internal database of users. As well, when you authenticate, whether it's directly through the UI here, or if you've authenticated with SAML or Cognito, it's going to come in with a particular role, right? So if you're using Cognito and you use Cognito to authenticate, you'll be assigned an IAM role. You bring that into OpenSearch dashboards, and you can map that external role, it's called a backend role, onto an internal user or onto an internal role. So as you're managing the security of the authenticated entity versus what that entity is allowed to do, either it's via the internal user database or it's via this external role that you're mapping onto your internal role, right? So when Ujjwal logged in there, that was a user that he created within OpenSearch security. So that one was an internal user, right? And again, you map the roles onto that user. Actually, you map users to roles, but that's the idea.
Yeah, so here in the screen you can see that this is the backend roles which John was talking about, where you can map those roles here. So going back to the UI here, let me. So yeah, if you look at it here, that I've logged in with the tenant one user, which has the role of tenant one role, which gives access only to that particular tenant one index. And if I just query the index, straightforward, it has access and it is able to do that. But whereas if I try to pull in this tenant two index data, you would see that it won't allow me to do that because I don't have access to that index. So pretty straightforward. You just define the roles, and then once you define the roles, you just map it to the particular role. Before we move on to the pool model, just wanted to introduce the another feature that is John has mentioned about the OpenSearch dashboards. So you can build OpenSearch dashboards here, and the definition of tenant in OpenSearch dashboard is basically a tenant is a space the OpenSearch dashboard provides you where you can create the visualizations or dashboards or any visual objects, and then use OpenSearch service roles to restrict access to the particular tenant space. And you can assign that tenant space to a particular role, and then that role is mapped to that user. That way, that user assumes that role and have access to that tenant space. So when I define this tenant one role here, again, I've defined a tenant one space, and then again created some random dashboard which tries to pull the data from that tenant one index and shows you that visualization. So since I'm already logged into the portal using tenant one user, I can show you that visualizations thing. Before I do that,
let me jump in with one quick point too. Sorry. So there's a lot of different tenancy is floating around a lot of different places here, right? So you have tenancy of the data itself, and then you have tenancy within the UI, and they are not the same, right? So if I create a tenant within the UI, it's just about what UI components and it has access to, that tenant has access to, right? So if I build a UI tenant, but I don't give access to the data, right, that tenant has access to some visualization that relies on some data that tenant doesn't have access to, the UI tenant, you won't get that visualization, right? So the UI tenancy is above and apart from the actual data tenancy model.
Yeah, thanks for clarifying that, John. You usually get easily confused between the tenancy of the data and the tenancy of the dashboards.
Confusing.
Yeah.
Yep.
So yeah, in order to look at that visualization of tenant one, when you log into the user portal with the tenant one user, it uses the global tenant space. You can choose the space which are assigned to that. So you can see that I can only, as a tenant one user, I can only log or choose the tenant one space. No matter how many spaces, tenant one spaces, or tenant how many spaces you've created for the OpenSearch dashboards. Since you assigned tenant one space for this particular user's role, I can only choose that particular tenant space here. And once I switch to that tenant space, pretty straightforward. You can go to the visualization. You just have this visualization. It's just a random visualization I put together, which pulls the data from tenant one index. So basically, with the role, I'm giving access only to this tenant space, which pulls the data from tenant one role. So now moving on to the pool model. For the pool model example, again, I'll start off with the roles here. So let me search that role here. So in here, I've created a tenant one, tenant three role, which is basically pulling the data from pooled index. So for the to demonstrate the pool model, what I did is I created an index with the name as a pooled dash index, and then under that pooled index, I've created a document for tenant 3, tenant 4, and tenant 5. And for tenant 3, I've defined a role which basically gives permissions to this index. And I mean, in order to enforce isolation, since under this pooled index there are a bunch of tenants are there, so we have to add another layer of isolation here, or the feature which is provided by the fine-grained access service provided by the OpenSearch security plugin. This feature, what I'm using here is a document level security. If I click on this view expression, what I'm saying here is hey, under this pooled index, the document which it has, it should match an attribute with tenant ID, with the name as tenant ID, and its value should be tenant 3. So since it is tenant 3 roles, I'm adding a document level security saying that hey, this document should pull all the documents which has this tenant ID as tenant 3. So that way, no matter there are other documents of other tenants, it restricts your access to that particular tenant's data. So to show this thing again, I'll log into the portal with, and again, let me back up a little bit here. So I've defined this role. Again, the same thing, we need to map that to a user. So I just mapped it to the tenant 3 user. And then now I'll go to the portal and log into with the tenant 3 user and show you that I can only access tenant 3 data or the documents, not the other tenant 4 or tenant 5, which has all other documents under the same pooled index. So let me log out here and then log in with tenant user.
Just to make the point, like the model here is, again, each document is going to carry some tenant ID, and you potentially could write all of your queries to filter for that particular tenant ID. With document level security, it just sort of automates that process of ensuring that the field has the correct value on that document. So it automatically filters out every other document that you have in the index, except the ones with it keeps the ones with the right tenant ID.
Right. Yeah. So before, sorry for jumping here and jumping the UIs here a little bit, but before I show you the pooled index data of the tenant 3, I will show you from the admin role or from the admin user. I'll show you that we can pull all the data. Since the admin role has all the access, I can pull all the data, and then I will log into the portal of tenant 3 user, and I'll show you that I can only pull documents which are related to just tenant 3. So This is an admin role. I'm logged in with the tenant admin user. You can see here. And then if I run these queries, basically I'm trying to pull a bunch of records or documents which are under the pooled index. If I do that, you can see that it has some random data, tenant3 document with tenant3 ID, which is under the ID, this particular ID, random ID. And then it has tenant4 data, and it also has tenant5 data. So the point I'm trying to make is like, when I'm logged in with the admin user, I'm able to see all the data here. But now if I go back to the portal where I logged in with the tenant3 user, which is mapped to the tenant3 role, which give access only to the documents, which has tenant ID as tenant3. So if I run the same query here, which is trying to pull all the records, you can see that it can only pull the records which has tenant3 as an ID. And it is not showing you tenant4, tenant5, but whereas it is showing you all the data which is for this particular tenant, where the document has a value of tenant ID is equal to tenant3. So yeah, that's how you're kind of using that fine-grained access control, like document level security plugin or the feature. You're trying to restrict that access to that particular documents, even though all the documents of all other tenants are under the pooled index. And
I think just to make the point. So like, what we're looking at, by the way, is within OpenSearch dashboards, you have different panes that enable you to do different things. What we're showing here is called the DevTools pane. On the left side, you can enter commands that are REST commands, right? Obviously, the GET. And then on the right pane, you have the response. So what we're actually doing here is interacting live with the underlying OpenSearch cluster, the OpenSearch domain, via REST API, right? All of these commands you could actually issue directly as REST API, with whatever technology you're using to generate those requests. And these are, we're seeing some examples of sort of some of that REST API. In this case, with the mget, what that's doing is it's going and it's pulling documents from OpenSearch based on document ID. On the right pane, you can see a search response. This is the typical format. You get a little metadata up at the top. If you want to scroll up, Ujwal, you get a little metadata at the top, and then you get a collection of documents. In this case, GET just returns documents. The documents are in OpenSearch. Again, this is search response. You could, over JSON, you would pull this in. Over the REST API, you'd pull this in, parse it, do whatever you need to with it. Again, point being, you're accessing the live domain, and the document level security is filtering down the set of documents that it's pulling out.
Yeah, from a domain perspective, demo perspective, just one last thing I want to show for the visualization for the pooled, for the pool model. So for the, again, now I'm back into the portal where admin user, which has admin access which has access to all the roles, all the indexes. What I did here is like created. So if I go back to the to the role, let me show you for the tenant3 role, I've assigned a tenancy called tenant3 for to see the dashboards and visualizations. And in this portal with the admin user, I've created a visualization and then stored that under this tenant3 space. I'll show you what that visualization here is. Since it is admin user, it has access to all the tenant spaces. Let me switch to the tenant3 space here. And if I go to tenant3, let me pull a visualization which I've created. So the visualization here, what it is showing is, since it is an admin user, it has access to the index, pooled index, and all the all the documents under this pooled index. It is able to pull all the data of tenant3, tenant4, and tenant5 in one just particular chat, or just one pie chart. Sorry. The cool thing now is like when I switch back to the tenant3 portal, where I logged into the portal using tenant3 user, which has access only to the tenant3 data, you will see that this this particular chart, when I open that this particular visualization, when I open up there in that portal, it only shows me the tenant3 data. So if I again jump back to the portal. Again, this portal is logged in with the tenant 3 user. And if I switch to this tenant, I'm just using tenant 3 because it is only given access to use this tenant 3 space. And if I go to the visualization here, see, you can see only the tenant 3 data. So the way you would use this in a SaaS world usually is like, as a tenant admin, you can, you build your dashboards with, which has data about different tenants, and you can leverage these dashboards to your individual tenants. And with the role, you're just restricting what data need to be pulled to that particular tenant. So when a tenant admin can log into their portal and they can see only their data. But from a SaaS admin, you are building your dashboards and sharing those things. So yeah, those are the demo we put together for you today. So yeah, that's all.
I want to just one more from me. I just want to like pause and sort of say this is and especially for logs, this kind of visualization and visualizations in OpenSearch dashboards in general are super easy to build. And this kind of thing, pie chart, you would maybe be looking at sort of if you're doing a logging workload. Typically, visualizations dashboards are for logging. If you're doing a logging workload, you might see a distribution at the center of the, I don't know, different AWS regions. You might, in the outer slices, have the different counts. In the even in outer slice, you might have different API calls or something like that. But building these, OpenSearch dashboards really is tailored for building these kind of visualizations. And sort of what Ujjwal was pointing out is you could build these dashboards at an organizational level. There is a global UI tenant that everybody has access to. So if you're an admin and you come in and you want to build a set of dashboards, then you restrict the data based on the authenticated user. So you have your different tenants, and those tenants will get a different view of the data behind those dashboards. But you can do the dashboard construction in a global space, or you can do it in a local space that's particular to a tenant.
So time flies when we're having fun, and we only have 1 minute to go. I want to bring up a question, and I'll give you about 30 seconds to answer it. So a question from Neil: is it possible for a role with a dynamically generated policy to map dynamically to the related tenant user in OpenSearch?
So dynamically generated policy. So all of the policy and all of that setup is via API. And so within OpenSearch, that mapping, dynamically mapping a particular tenant, actually, you could do that on the fly. You could create the role, you could create the access, you could do all of that dynamically, and then that tenant would be limited in that way. So you could do it, yes. How's that for a 30-second answer?
Yeah, I think it was good. So I want to thank John and Ujjwal for joining me today, where we've talked about multi-tenancy with OpenSearch. And thanks to all the viewers as well for joining us and the questions you put through in the chat. So, John, any last words? 10 seconds.
No, just super grateful for the chance to talk about it. I think tenancy is a fantastically interesting topic, and it covers so much ground. There's so many different kinds of containers and kinds of ways of managing the filling of those containers. And especially within a sort of SaaS context, I think SaaS is super interesting just as a means of managing and marshaling resources against a particular set of demands. So I love this topic area. I think it's really cool, and I really appreciate being able to come on today.
All right. Thank you all for joining, and have a great rest of the day. Bye-bye.